right, we'll go ahead and get started. We only have 25 minutes. We're going to jump right in. I apologize a bit because this talk is at least a 50-minute talk. So batten down the hatches. We're going to move quickly. But I've got on every slide, let's just start the first slide. You'll see a QR code. That's to download the slides. You can also go to the website for this conference and download the slides there. Either way, you'll see it on every slide, so don't worry about I'll have a bigger one at the end too. So what we're going to do is talk about modernizing your .NET skills. How many here are .NET developers? Sweet. Okay, you're in the right room. Cool. So my name is Tim Corey. I teach software development as a job, which is awesome. And a lot of what I do is .NET. So we're going to talk about, there's a lot's been changed since, .NET 6, .NET 7, .NET 8, .NET 9. Guess what's coming in November? .NET 10. So along with Visual Studio 2026 and a whole bunch of other changes. So we're going to get right into what we should be thinking about. And there's some big things and little things, and these are just the tip of the iceberg of all the things that are going to be in here. So let's start number one. I don't know if you've seen this yet or not, but SLNX files. We've all seen solution files. SLNX files are kind of awesome. What Microsoft did is they looked at that SLN file, which is a big, confusing mass of XML, and they went, why do we have to have all this stuff? And even worse, when you have a large project and you're trying to synchronize changes and you have a merge conflict on the solution file, you have a mess because you don't know what to do with that. Well, this is an entire SLNX file for 3 projects, I believe, in one solution. That's it. That's all it is. Good luck trying to even do a file new project and seeing something that short in SLN. They're huge. So this, really easy to read, solution, project, 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 and there's a path. Done. This also allows for a lot of other things in there, but what it does, it takes all the defaults and says, let's just make them defaults instead of specifying what the default is. You can obviously add more things back into this, make it more complicated, but by default, these are pretty awesome. You can upgrade your solution file to SLNX just by saying file save solution as an SLNX. Number 2, this may have terrified some people. If you do APIs, they remove Swagger. Oh no! Good news is, with one line of code, you can bring Swagger back if you really miss it. What they did was, Microsoft has this weird problem, especially in the community, in that people think if it comes from Microsoft, it must be the only way of doing things. It's the right way, it's the gold standard. But we need to have more flexibility than that. And Microsoft said, hey, what we can do is support the open API specification and allow you to make the choice of how you want to then implement a UI for that if you want to. And so we have 4 options. They're great out of the box. Kind of out of the box. They're third-party packages. Excuse me. Swagger's still there. We also have NSwag, Redoc, and Scalar. So feel free to pick one of those or build your own or look at another third party that's being built. But there's some great options out there. I do have links in some slides, not all of them, but in some slides to a more info. If you want more in depth, I've got like an hour talk on YouTube just on this topic, showing you how to use all 4 of those and talking more about it. Obviously, we're not going to get into that in 1 minute. All right, number 3, Aspire. Who uses Aspire? Okay. Who should use Aspire? Everybody raise their hands. Yes, Aspire is awesome. So Aspire is, people are confused as to what Aspire is, so let's talk a bit about that. Aspire is for local development. People ask, well, how can I deploy this to the server? That's not how that works. It's for local development. People ask, well, how can I use this to deploy my services and systems? That's not the original intent of Aspire, although they are starting to work into making that part of the process as well. The whole goal of Aspire is to make our jobs as developers easier. Now, our jobs as developers tend to be all over the place, from building the code to deploying the code to maintaining the servers, which is why we start asking these not dumb questions, but questions that are outside the scope of what Aspire was meant to do. What Aspire does is, and I was going to put a screenshot here, it wasn't quite representing it. Essentially, in a few lines of code, it says, here's what your application looks like. Let's wire all these bits together. So your API and your database and your whatever else, Redis, whatever you're bringing in, whether it's Docker packages, whatever else, it does all of that in .NET code, which you can then check into your repository. And so then the rest of your team, when they download that code from the repository, they can spin that up very quickly. But not only that, when you just hit File Run, you get a project dashboard that lists every single different launchable application you have. So if you have an API and you have a front end, it's going to list both of those with their ports. You can launch it right from there. But then it also has all the console statements from all those different projects you're running. Plus it has a structured log viewer for all those different projects. You can investigate what's going on. It also has all your traces in one spot. And it also has all your metrics for your application. This is out of the box, a few lines of code. Check out Aspire. They're going even further down the road with things like deploying to Azure. And it really is platform agnostic. You don't have to be just Aspire. You don't have to be just C# applications. You can do a lot more with Aspire than just that. So don't get caught up in the idea that Microsoft created it, therefore it must be only for Microsoft stuff. So that is Aspire. Number 4, minimal APIs. I love these things. I have built APIs for decades now, and I have gone to almost entirely minimal API for everything I do. And the reason why is because Microsoft realized, we're going to see this in the next few slides, Microsoft realized that they had a problem. And what that problem was, they started looking at what does it take to get started with .NET. And they started to realize that a file new project involved hundreds of lines of code. And it had all these different moving parts that, once you're a .NET developer for 5, 10 years, you're like, oh yeah, I don't understand every one of those parts. But what does it mean for a new developer? It means you have to learn hundreds of parts, and that's a huge hurdle to get into .NET. And that's one of the things they realized was a stopping point from new developers using .NET. Minimal APIs, they realized, hey, we got all this ceremony around an API. We have, the constructor itself. We have all those naming conventions. We have all this, implicit stuff and explicit stuff. We have decorators and all the rest of stuff. When really, this right here is an entire API. Everything. That's an entire working application. Now, the one thing I did do was say dev.print messages. It's calling out to your library or whatever else you want to do, but that's an entire API. That's from declaration to wiring up to HTTPS redirection to actually mapping a GET command. All of that in one little section. So what does this mean for developers? It means easier to maintain. It means you can group things in a different way than just, oh, it has to be in the home controller as part of the home routing path. Well, no, you don't have to do that. You can make a smaller system that's just these things that are logical to whatever it is. So minimal APIs, check them out. They're full featured. They can do everything that controllers can do. I think there's no more limitations. There was a couple limitations were tiny little edge cases that have been eliminated in .NET 9. .NET 10's even improving minimal APIs. All right, who loves file scope namespaces? Sweet. Yes, I love these things. Essentially, all they do is save you whatever spaces that is, 4 spaces by default of horizontal space. And I have people fight me over this. Like they really want to have their old namespace style, the scoped namespaces, which is fine. You can still do that. And that's one of the things that is wonderful about the new way Microsoft is developing, and that is they're not breaking stuff. Like if you have your old stuff, cool, use your old stuff, use it the old way. But one of the things they found was, again, we look at all the complexities of what .NET does and how complex a startup project is, and they realized we're only putting one namespace per file in, 99% of the cases? So why not just put a semicolon at the end instead of having curly braces that surround the entire scope? So if you use the file scope namespaces, you save 4 spaces horizontally for your entire application. And if you need 2 namespaces for one file, you're doing it wrong. I mean, if you need 2 namespaces for one file, then just use the original way of doing things, okay? So, but again, maybe rethink your process if you have to have 2 namespaces per file. There are exceptions to the rule, but that's a very small exception pool. All right, number 6, top-level statements. So this is an entire console application. You've probably seen file new project for a console application. Again, Microsoft had this idea that we've got too much ceremony. So even in a file new project for a console application, which was a simple little project, we had a namespace, we had a class, we had a program, or we had a method name, we had the parameters for that method. We had all this stuff that you had to kind of swim through in order to get to the right spot to put your hello world to get started. Now, that benefits the very new developer because we're not showing them all the stuff they're not using it anyway. But it goes beyond that because of the fact that it makes all of our applications have less lines of code, which means there's less to review when something goes wrong. So I have a whole rant on this if you want to go watch that YouTube video, because one of the things that I talk about is the fact that people push back over this. They're like, oh, we're hiding stuff. And technically, yes, they're hiding one thing, and that is the parameter that comes into the args parameter that comes into the main method. However, we have a method, and people fight for, we need to see that method, but that method can't be called. And we have a class that we really shouldn't be calling or using, and we have a namespace which, if you want that namespace, you bring the using statement back in. So why do we have all this stuff we can't use because it's not the same as a normal one? It's not a normal class, it's not a normal method, therefore why are we treating it like it's normal even though it's not? So therefore, I would encourage you to start moving that direction. Again though, Microsoft is not breaking compatibility. You can have your .NET 3.1, Core 3.1 application, you upgrade it to .NET 9, .NET 10, it will still work with the whole structure. You can even say, don't use top-level statements. It's a confusing, unchecked checkbox, but if you do, you can still get the class, the namespace, and the method name. So top-level statements. This is a newer one, and this I almost jumped up and down physically for joy with. How many of you have ever tried to instantiate and put an initial value into an array? And how many of you go, wait, what's that syntax again? Is it new square brackets, then quotes, then curly braces, and again, why? And so what Microsoft said was, hey, what if we just use square brackets for everything and call that good? So when you instantiate a list of string, you can use square brackets. If you instantiate an array of string, you can use square brackets. If you have a collection, you can use square brackets. Whatever it is. Now, this is actually a really complex piece of architecture they did, because behind the scenes, what that is doing is using the most efficient way possible to instantiate that specific type. So if it's an array, it's going to be different than a list. And so they're actually doing some translation behind the scenes that we don't have to care about, because we're using .NET. And .NET lifts us up out of the muck of all the twiddly configuration stuff and lets us just say square brackets go. Now, along with this, I wanted to throw in a kind of a bonus one here. This also works with the spread operator, which is another one that I don't use that often. When I do, I'm like, oh yeah, that's great. 2 dots. So you do 2 dots in the names, and 2 dots in more names, and that's going to combine those 2 arrays or 2 lists into a new string array. And again, notice we've got 2 lists of string going into a string array. So we can chuck things all over using our arrays, and it just works. Again, it's making our lives a whole lot easier. So, collection expressions. That's number 7. Number 8, random methods. So, random used to be more difficult to get right because it's not thread safe by default unless you instantiate it properly and make sure you're doing all this stuff. Now we have just random.shared, which is thread safe. You can just use it. There's no need to instantiate a random. You just go ahead and say random.shared. You're good. But there are 2 new things they've added in random in .NET 9, and that is, number 1, get items. So notice there, I'm not getting into all the code, but combo is a list of items, and I'm saying just give me 2 random items out of that list. So, and you can, whatever number you want, just grab that number. So that gives you a subset of your items randomly. And again, random.shared.shuffle. So for all you, those of you who are creating card games for demos, shuffle. There you go. So, random. All right, that's my random update to my. Okay, Thank you. That one pity laugh. All right, number 9, alias any type. So aliases have gone a little out there. We always have had using directives. So using system.net and demo API. These are normal. But then in .NET, I believe it was 6 maybe, we add the ability to add a using static. So we have a lot of console.writeline, console.read lines in a console application. We could say using static system.console, and now we can just put in our code write line and read line because we have that using static. But then we added the ability to use alias any type. So for example, please don't do this, okay? This is one of those, so you can do it, don't do it. But what you can do is, we've got a tuple. We could name that tuple. We call it person. Now we can use that tuple as if it's a named item. Okay, that's not the greatest of examples. It's an example that shows that it works, okay? I have found this is an edgier case that you might not want to use that often, but it's possible. The other thing is you need to know it's there because if you see it, you're going to go, what's going on here? Especially when you see something like read line or write line in code. Why is that working? Because of the using static. Well, the same thing down here. You can alias any type you want. So you could alias a string and call it a double, I guess, doubles, you know, and really mess with people's code. But alias any type is there. All right, primary constructors. Here's what I go back and forth on. You've probably heard a lot about it. You've probably seen a lot of people talk about it. I don't know, how many of you have used primary constructors? Okay, how many love them? Okay, I got a couple. All right. I'm on the fence on primary constructors because of the fact that I don't think they're fully baked yet. Okay, they're getting there. Maybe .NET 10, I haven't seen yet the changes I want to see in primary constructors, but maybe. So what we got with primary constructors, the idea is that if you're using dependency injection, and let's say you're injecting, I don't know, your iConfiguration, and that's all you're doing at your primary constructor. So you have a primary or constructor that says iConfiguration config, and then you assign it to a variable that you put into your class. You then access the rest of your class. Well, with primary constructors, we can say, you know what? Let's just put it at the top here, right next to your class declaration. No need to declare a constructor. The problem with this is what it does, it makes this variable, first name and last name, available then for the rest of your class as a private variable. But it's mutable. Don't love that. So you can still make it read-only, and you can change the name like this, private read-only string underscore first name equals first name. Okay, that kind of works. Or you can force them to be read-only by assigning that same name to itself. So if you say private read-only string first name equals first name, then now first name is read-only, okay? And you can actually still use a regular constructor and bring that in using the this command, so you can bring in the primary constructor into a regular constructor. So you can do all the same stuff, but at this point, maybe we just use the original constructor and call it good. So there's a limited use case. I think that what's going to happen eventually, I'm not sure if it's going to happen in 10 or not, is I think there will be some type of decorator here for make this read-only. And I think that would solve 95% of all my concerns with it or quibbles with it. Because I don't want my items I'm passing in my iConfiguration to be modifiable. Okay, so I want it to be read-only. So that's the only thing that I think that would be needs to be upgraded with that, but primary constructors do exist. There is a reason for it. What Microsoft is doing is looking at all their code again and saying, why do we have all this boilerplate? Why do we have these ceremonies? Why do we have all this stuff when really we don't need to? Because that tells you exactly what's happening. We're bringing in first name and last name. It's just how you bring it in that's then the question. So that is primary constructors. Number 11, keyed services. So use dependency injection, and you have two different dependencies that you want to bring in that use the same interface. Well, you can actually name them. So I've named this first one, the MySQL one, MySQL. I named the second one, SQL. And then when I can ask for it, by the way, this is a minimal API, but I can ask for it by saying from keyed services and ask for it by name. So you can do that if you want. You can still then ask for just the iSQL and get the array of them, or the first one back, whichever you ask for. But keyed services allows you to actually name them and get a specific one back. Okay? And again, there's a video with more information about that. All right, Blazor web apps. How many of you use Blazor? Okay. How many of you are web developers? All right, a few more. Then use Blazor. Okay, check it out. So Blazor, I'm going to give you a brief history of Blazor. Blazor came out from an idea that Steve Sanderson had, where he's like, what if we could just do this crazy thing? And he actually created Blazor WebAssembly. But then they released Blazor Server first, because it was more baked at the time of launch in .NET 6, I believe. So Blazor Server, the idea is that we use SignalR to connect between the back end and the front end. So it's an open connection for every client as long as they're connected to the server. But what happens is we get all of the rich UI ability of a client-side application, but it runs fully on the server. The benefits there are we can have things like connection strings and talk to the database directly and all this other stuff on the server secured, but yet still have the ability to have pages that change without a full page refresh. That was Blazor Server. The downside is you've got that constant open connection with SignalR, which means that if you have a glitch with your internet, all of a sudden it gives the dread, we need to reconnect you, and then it loses session potentially. The other problem is that if your server has more than 10 to 20,000 people at a time, then you've got a load problem. You have to then offload that to like Azure, SignalR service, or something else. So then we had Blazor WebAssembly. WebAssembly is fully client-side. Your C# code goes down to the client, which means you can't talk directly to a database. You gotta use an API, just like Angular, React, or Vue do, but it acts the same as Angular, React, or Vue in that you have a full client-side experience with C#. So the same C# code you write for doing server-side stuff, you can use that same knowledge to write rich UIs on the client side. The downside there is it takes a little bit to load because of the fact that it's downloading your entire UI to the client. So what they did was they said, hey, what if we just mashed those two together and had both? And that's what Blazor Web Apps are. Blazor Web Apps, they even take a step farther and they have server-side rendering. Server-side rendering is when you have like an MVC or a PHP or something else where the server builds out the page using, again, PHP or MVC, but then it just sends the client HTML and CSS. But then if you want to do something, it's a full page refresh to go to the server and get the new page. That's server-side rendering. And Blazor can do that now, which means it's very fast. That's a very fast interaction. But then we have auto components. So just a little bit on your page can be interactive. Because your whole page doesn't necessarily need to be interactive, just a little bit. But that little bit can be an auto component. What that means is, at first, it's a Blazor server component, which has that SignalR connection back to the server. But behind the scenes, while the user is using it or while it's on the page, it downloads that same component as a Blazor WebAssembly component, and then it swaps them out. So now you have a very fast load of a SignalR component, but then you have the offline capabilities, or at least the faster capabilities with no connection to the server of a Blazor WebAssembly component in one component the user never knows. So it really elevates the game, and really, if you're talking about web development in C#, I think this is the place to start looking. I'm not saying every website should be Blazor, but I'm saying if you're going to do a C# website, that's the very first place you should go. I don't see a need for MVC hardly at all except for legacy. Okay? I don't see a need for Razor pages hardly all except for legacy, because this has covered all those eventualities, but also gives you the ability to elevate and bring down components as you need to fit your future needs, not just the needs of today. Okay, so that was the top 12 in a lightning round, but now I have 6 more, because why not? I actually said 15 in the talk. I gave you 18 because bonuses are good. So nullability. Learn how to use nullability in C#. People complain about how you now have green squigglies everywhere, where it says this could be null, and you're like, stop telling me. But what that's doing is Microsoft said, hey, what's the #1 reason why applications crash? Nullability. So I said, what if we just created tooling that told you when there might be a problem so you could fix it? And all the developers said, let's ignore those problems until they become problems. And we still crash our applications. Learn how to use it. It's awesome. Upgrade improvements. It's easier than ever to upgrade your application to .NET 9, .NET 10. With .NET 9, they've now extended the STS, a standard term support version, from 18 months to 2 years of support. That may sound weird. What that does is it means that when you upgrade to .NET 10, you have 3 years of support. When .NET 11 comes out, in 1 year later, you'll have 2 years of support. What does that mean? You can upgrade to .NET 11 and have the same amount of support as you do for .NET 10. So that way, you can more easily upgrade to the next version and not worry about being outside the support window. And the upgrades are super easy. The biggest problem is your code, which means if you upgrade more often, you'll have less problems because you can fix them when they're small. Wait until they're large and it's kind of too late. All right. Performance improvements. Every version of .NET makes things faster. .NET 9, optimize the for loop. That's awesome. I mean, it's a tiny little thing, but we optimize the for loop. So, anyways, file dialogues in WPF are finally WPF file dialogues, not WinForm dialogues. Native AOT. For those of you who want faster performance on startup, etc., native AOT. Quick Grid is part of the new change as well, and tons more. Lots and lots more. And this is all before .NET 10. This is all .NET 9 back. So this is all stuff you can use today and hang on to your butts because .NET 10 is coming with lots more changes. So I encourage you to keep up to date. There's the slides if you need them. But otherwise, thank you for being here. I'll be here. Ask questions. Feel free to shout out and etc. All right? Thank you. And don't forget, there is a rating system for these sessions. You feel free to give me the thumbs up or thumbs down, yell at me. So if you want to yell at me in person, though. So.